Hello everyone, it's June the 9th. Alright, nothing more to actually say today. Quite a normal day, you know. The only thing that was mentioned is I'm now decision I made and I am proud of it. Well, because I can do it, I had doubts maybe last week. I was thinking about it, but I had doubts. But I think it was 2 days ago. I tried it for the first time without the bike and just body weight, and it was fine. I mean, by the way, the building I work at has 8 floors, but technically speaking, it's actually 10 floors because they don't have the first floor starts on the third floor, so it's like 10 flights of stairs. So 2 days ago I did it just with body weight, and if it was I was out of breath, but also I try to do it pretty fast. And yesterday I tried carrying my bike. Now, fortunately, the bike was not heavy, and I found a pretty good spot so that I can carry. And it was okay. It was okay. I was able to do it. And today I did it again. And honestly, it was a little bit easier today than yesterday. So I think this is going to be for the remainder of the time. I'm going to just not use the elevator. I think it'll be fun. And I want to see how this one leads to eventually. I think I'll still get tired eventually, but I expect the breathing to be much, much better. Right now, I was like horsing at the end, really like a horse at the end. But let's see, I'll have a couple of months to get better. So they're cut different stages, right? So the first stage is just try not to horse at the end, and then we're gonna try to like say move faster, and eventually we'll try to do 2 steps at a time. But this is something to work up to. So other than that, nothing too special. And finally, start to take on real projects, take on tickets, and try to solve the real problems that the company has. All right, anyway, let's do this. There's a question number 3. Longest substring without repeating characters. Very nice. Very straightforward problem. Given S, find the longest substring without repeating characters. Now, most likely, I think this shall be longest substring. I mean, we can, because it's a substring, right? So usually substring, sliding window, DP. I'm going to choose DP. I'm going to say we have a global longest and also the longest substring ending at each position. That without repeating. Okay? They say ending at each position and have the longest substring. That's without repeat. Okay. Now I have the such. Not banner such. The last occurrence. The last occurrence of this thing. Yeah, so it will be like this. The last occurrence here, so this will be this. So the longest substring ending at each position, right? Ending at each position can be determined. So this is almost exactly the same as problem I solved, I think just a few days ago. It's almost exactly the same. Unique substring. But overall, it's exactly the same. So I'm going to solve this using the good old is that considered DP? Oh shoot. That's not, it should be 8. All right. Now we're going to 10. Absolutely horse. I like how the Sika boys say this. We don't even need to. We just need to have a index. Okay, indices. Let's call it. Oh, we can call it DP. No, that's not DP. we're gonna call it so for each one we just find the most recent occurrence. Oh, actually that's not true. That's not true because it could have repeats. And so with each one we have the longest unique, right? And then now we have the new one. Now we have the new one. Oh, hold on. This actually, the idea is not right. If, right, so in the previous one, I have the longest substring, I have a length, and now I have a new letter. Now, if this new letter, the last previous occurrence is further out, right? It's further out of the substring that we have than the substring length plus 1. If it's within, then we have to reduce. Okay, so we're going to have last previous pre-occurrences. That's going to be let's use a dictionary. And then we also need to have the res and current. Okay, and let's say for I, letter enumerate as, all right. And then we just say if letter, no, hold on. So everyone shall be minus 1. Yeah, then we can have the length. Wait, hold on. Is that the length? Yes. So I have a minus 1. So maybe I should use default dict. Hold on, need to get my cat out. What the hell are you doing, man? We'll say default dict lambda minus 1. Okay. So now we know the length. So it should be the minimum. Or the maximum. Oh, hold on. The minimum among the two. Right? It should be the minimum among the two. Because it's from this to this, yes. And then we need to go the previous. So we need to find the minimum of the two. So in that case, shouldn't this be math.inf? All right. So we just say for this, say current shall equal to the minimum of current and I minus pre-occurrences letter. All right. And rest shall equal to maximum rest and current and pre-occurrences letter shall equal to I. And we just return rest. Okay. Let's see. This is 3. S length could be 0, so I can go this, and that shall be 0. Right? And then I can go 1, shall be 1. Okay, so here, what's this S? Length S. All right, we passed some, we failed some. Okay, the first one. Oh, minimum of these two. Oh, that's not correct. Okay, so I'm gonna redo this. I'm gonna say if I minus pre-occurrence letter, right? If this is the length from this towards here, which means it's this length, right? We say if this length is larger or equal to current, right? Then current plus equal 1. Else, if it's smaller, right, then current equals I minus pre-occurrence letter. Ooh, it gets even more wrong. And off by 1. Hold on. Current is the length of this, and from I towards the previous, right? So that's just the length. It doesn't contain the letter. So from here all the way to a certain point. So we shall say if this length, all we want to say is if the current includes that, right? If the current includes that, then it has to be this, has to be I minus. If current doesn't include, which means if I let's make it, let's just do this. Let's use index, okay? So it's I minus 1, right? I minus 1 minus current, right? So we say current length, if it's 3, from here, 1, 2, 3, right? So this is outside, so plus 1. So that's the bound, it's the boundary. So we say if the previous one, right? If the previous one is outside this boundary, right? If the previous one is outside this boundary, so we say if this is larger than previous letter. And of course, now we can say find this oopsie doozy. Let's see if this one works. This one works. So here's this is better, but we can now analyze a little bit more. Basically just say I minus pre, so that's the length. If this length is larger than the current length, right? It's not larger equal to, it's larger than the current length. Yes, if it's larger, because if it's equal to, then it's still inside. Except from this to this, that's the previous length. If this is larger than, yes, current plus 1. That's true. If it's equal to, then we cannot take. Yep. Okay, so what we're gonna do is put it here and run it. I've come a long way. That was the first time, 2018. It was 4 years ago. August, first time trying it. Oh, terrible. Don't know how to do it. And using something very convoluted to get it resolved. And then learning, and then I think I called it a day. And the second day, woke up, tried it again. Probably saw the solution back then. And then, oh yeah, back then I used 2 different languages. And then 2021, it's already better. Okay, just see how 2021 works. See after a year, any improvement. This is 2021. Left bound. I compute the current left bound. And I get the rest is maximum this. I minus the left bound is maximum of these 2. Oh, this is actually a previous left bound. Good. Yep, it's pretty good. And this is today's solution. It's the same. Proudly, LeetCode 3. So this problem is very similar to the one to 226. Actually, I don't remember 226 what. I think it's maybe 361. Count distinct. Nope. That's the one I saw yesterday. 60. Minimum card pickup. Nope. 62. Appeal sum. It's like appeal sum. 2262. First and 2262. We record, right? Record the index of the last appearance of each letter and the length of the longest substring, unique substring, ending at the position right in front of the current one. Now we check if the last appearance of the current letter is within or outside the unique substring ending at the previous letter. If it is outside, then the length of the unique string ending at the current letter is one more than that of the string, right? Ending at the letter before. However, if it is inside, then the current maximum length must be from the current index to the index of the last occurrence appearance. Hopefully this makes sense. It makes sense to me. I was able to solve both problems, so that was a good thing. Okay. All right, so we call this, we're done with this. So we'll just do a couple more. What's this one? You're given a string, a large integer, and integers are good if it meets the following condition. If it is a substring of num with length 3, only one unique digit. It is a substring of num. An integer is good if it is a substring of num with length 3. It contains only one, so it's just one digit repeated 3 times. Alright, so counter this. Right, we counter this and find the largest. So what? 4. Alright, how do we do this? I'm going to say counter num. Right, I'm going to say counter. Oh, we might be able to do, I don't know, counter. Yeah, I think we have to do counter. Okay, we'll counter num. And then say for d in range, I can't just do this. 9, 8. So stupid. Range 9 to 0. If strd, if, we can say, oh, hold on, it has to be continuous. Might as well just iterate through. Oh, group by. Oh. I always forget. Right, it's like I have to search again. Group by. So for kg in group by. Alright, so it's going to be group by. So from ita tools import group by. Alright, so we're going to delete all this. So we need to find the largest. So largest key equals, let's say, -1. Okay, and for g, well, I have to say kg, right? For kg key, key kkg in group by num. Okay, group by num, and then we're gonna list it. Oh, have k. Oh, that's fine. We say if len list g is equal to 3, is larger or equal to 3, right? And kk is larger than k. Oh, kk is larger than k. Yeah, let's just int it. Then k equals int kk. Right, blah, blah, blah. We say return strk times 3 if k is larger or equal to 0, else empty string. All right, I have confidence, so we'll just go directly. Where is the problem? Here, this one. Run this. Yeah, shall be right. There we go. I'm now gonna go back for this. So use group by. Otherwise, you probably have to write yourself. Maybe it's faster, but it's all when. Doesn't matter. Okay, so this one's done. What's the time like? I don't want to do too long today. Maybe we can handle another one. Let's try this one. Count nodes equal to average of subtree. Given the root of a binary tree, return the number of nodes where the value of the node is equal to the average of the value in its subtree. The average of n elements is the sum of n divided by n rounded down to the nearest integer. So it's the division, integer division. Subtree of a root is a tree considered the root and all its descendants. So we want to find the number of nodes where the value of the node is equal, right? Is equal to the average of the value. And so basically, for each node, we need to know the total sum, and we need to know the total count. And then yeah, I guess that's it. I mean, I didn't really think too much about it, but we have solved the other two problems in the past. We have solved the sum problem, and we have, I'm not sure if we've solved the count, but count shall be pretty straightforward, and this one we don't have to do any test. All right, so here's what we do. We want to return, right? So self.res, easiest way. So def dfs. So we say if not node, return 0 and 0. So sum and a number of nodes, right? Otherwise, we're gonna go left. So we say left sum left count equals dfs, right? dfs left, right sum right count equals dfs right, and then we're gonna return. I'm gonna say s equals ls plus rs plus node.val, right? And count shall equal to L count plus R count plus 1. Right? I say if node.val is equal to S divided by C, then self.res plus equal 1. And then return S and C. Okay, now we're going to call it dfs root and return self.res. Okay. How many examples we have? 2 examples. Yep. You want to try? No, I don't think we need to try. This is pretty straightforward. Very deterministic. Oh, it's taking a while. So it's not on the server side, maybe on my side. So anyway, so this is very standard. Right? It's a very standard problem. So this is a very standard DFS problem. Entry. We basically need to find the sum of the tree and the count of the nodes. Both are easily done via DFS. It can be considered an easy problem. Probably not. Easy problem will be just 1. This is like 2, so yeah. Okay, I guess that will be it. I don't want to do another one, so let's just call it here. 33. Yeah, it was good. I'll see you guys tomorrow. Adios.